All right, thank you for coming, and thank you to the organizers. It's great to deliver an update on behalf of the RabbitMQ team. So let's get started. So first of all, who am I? So you may know me as the person who tells everyone on the mailing list 20 times a day to read the logs, right? But I'm also a senior engineer at Pivotal, working in the RabbitMQ team. I have been a RabbitMQ contributor since about 2010, if I remember correctly. And I use this handle on most services. So what are we going to talk about today? A little bit about what our team has been up to since 3.7.0, some future directions, and what you can expect in 3.8 and maybe even beyond that. So what's the state of 3.7? But before we discuss that, let's take a look at what 3.7.0 brought. We had some themes that we never really explicitly mentioned. So we wanted to make RabbitMQ easier to operate. And that comes, I think, in my opinion, primarily in two areas. First of all, you have to have a service that's easy to deploy, and deployment these days happens. Machines do that, right? Not humans. So yeah, day one operations. But beyond that, you have what at Pivotal we usually call day two operations, which is basically everything else. That's day two to infinity. You need to have a service that you know how to operate, that you understand the limitations of, that you can monitor and so on, because if you don't have any of those things, eventually your experience will be less than great. And as with any release, we wanted to make things more stable and set some things up for future changes that we will be talking about today. So specifically, we have a new config file, which is, yes, easier for humans to use, but is also easier for machines to generate. We have a peer discovery subsystem, so in environments such as AWS or Kubernetes, you have to do very little for nodes to discover each other. We have stats that are stored on every node individually instead of just one node, which was a pretty easy way to overload your cluster. We have operator policies and limits to enforce some of the limits because as was mentioned in the previous talk, sometimes applications do things that developers don't expect, and that affects the overall stability of your system. So operators have to have something in place, some guardrails, basically, and there were none. There were other changes as well, but that was 1 year ago, almost 1 year ago. So what have we been doing in 3.7 releases ever since? So we focused on things that are not necessarily code, but are very important in our opinion. So best practices, documentation, non-breaking changes, as always, improving the ecosystem, which is a pretty strong point for RabbitMQ. So for example, we now have a dog guide and a pretty well understood practice of blue-green deployments. This is a way to upgrade where you have your original cluster, you bring up a new one, and you switch traffic over. In my opinion, this is the lowest risk way of upgrading. If should anything go wrong, you can always go back to the system you already have. So highly recommended. We have a repository, which I'm not yet ready to announce, but if you take a look on GitHub, you will find a repo named workloads, and it has various settings and recommendations, for example, for lower latency environments and so on. That a couple of members, a couple of engineers at Pivotal have been working on. And sometimes it's remarkable how much you can improve and configure things if you understand your workload well. We also have some doc updates. My favorite one is monitoring, because it's a bit surprising to me, but a lot of people, we still see a lot of people go into production without monitoring. Don't do that, right? It's not going to end well. So we asked ourselves, why is that? And we figured, well, we don't really have any monitoring docs. How about we add some and see if that works? We also have a guide on updates to the production checklist, and a runtime tuning guide. I don't think that is live, but it will be soon, definitely before 3.8. We also have a number of non-breaking changes. I don't think it's worth going through every single one of them, but yeah, we have Erlang 21 support. We have a Kubernetes deployment environment, which has been refined. We're using the new config format in more and more places. We package cutting-edge versions of Erlang. You know how I learn about new Erlang releases these days? Our build system publishes a new update whenever there is a tag in the OTP repo. So I don't have to look for announcements. But that's not why you came to hear me speak, right? You are interested in something cooler than that. So what would you like to improve in the future? Well, honestly, the general idea is the same. Make it the system that is more reliable, easier to operate, address some known scalability problems, simplify upgrades, and in the end, drop some homegrown distributed system algorithms, which it's even worse than going into production without monitoring. It's very hard to get those things right. So if you find yourself in a situation where, maybe I should implement a new distributed system algorithm, honestly, maybe you shouldn't try to look for something developed in the last 40 years that might be suitable. Yeah. So this is the most painful slide, but I have to go through it. So if we have this general direction, we have to also acknowledge what doesn't work very well in RabbitMQ today. Otherwise, how can we possibly improve on it? And, well, we have the suspects that I'm sure you know. In certain failure scenarios, recovery of RabbitMQ nodes is not a very well-defined process. And it depends on a couple of things. Well, homegrown algorithms and mirroring, but also the schema database used internally. We will talk about that a little bit. So, which is why some resiliency tests RabbitMQ currently doesn't pass them. Well, 3.7 doesn't. Also, once you have a node failure, if a queue mirror, if a follower has to sync with the master replica, it has to transfer a lot of data, way more than necessary, even if it has been offline for a few seconds. So that's clearly not great because it can cause basically a thundering herd kind of problem. So the schema data store used internally has originally been designed for very different workloads. I think it's a reasonable system in many ways, but RabbitMQ users expect something else. They expect it to work differently from how it works today, so it would be nice to find a way to address that, right? And lastly, RabbitMQ currently doesn't have a single write-ahead log or operation log, depending on what database you're more familiar with, which in particular makes backups harder, incremental backups. So it would be nice to get there one day. So scalability is another area. Mirrored queues use an algorithm, well, a variation of an algorithm called chain replication. And basically, the way it works is nodes form a ring, and messages pass around the ring twice. Well, messages pass around the ring, then confirmations do. If you think about it, that's a linear algorithm. We all know how well that scales when it comes to growing your cluster. It's not DC aware. It was not really designed to be DC aware. It uses a lot of bandwidth. And another area, which was mentioned in the previous talk, we support multiple protocols. We really want to support all of them to the best of our ability, but currently they all build on a core which is very protocol specific. It would be nice to both reduce overhead and simplify some code and avoid some, because protocols do not exactly match each other, right? Even though, in my opinion, messaging protocols are quite similar. Yeah, you can run into correctness issues where one protocol expects things that the other one cannot possibly deliver on. Whew. So with that out of the way, we have a number of improvements that we're going to discuss. The first one is Quorum queues. You can think of them as mirroring 2.0. They use a consensus protocol called Raft. I will very briefly explain what that is. Auth2 support, mixed version clusters. So basically, yeah, this is not a promise of delivery, but by the time 3.8 comes around, maybe you will be able to temporarily have 3.7 and 3.8 nodes in the same cluster instead of doing blue-green, or just shutting down all 3.7 nodes and then starting them back one by one. And protocol agnostic core is another area that we're working on. So let's start with quorum queues, and specifically, how do they compare to the mirrored queues we have today? We will talk about Raft in a bit. So with Raft, recovery from failures is well defined. In fact, I think most of the Raft paper discusses how exactly you recover from failure. The happy path is quite trivial. I will show it to you in 2 slides in a bit. When a follower has to catch up with the leader after failure, it only transfers the delta, so as little as possible instead of the entire contents. So that's a huge improvement. It passes certain resiliency tests. I'm not going to claim it passes all of them, but those we have tried and those that are well known in the community, it does pass. So there's that. And because Raft uses a log of operations internally, it opens the door to a unified op log, which makes incremental backups possible. We are not there yet, and Raft itself will not get us there. Well, Raft alone will not get us there, but now you have a system that is increasingly built around that abstraction. Compared to mirrored queues, there is no ring topology. Replication is parallel, which I think is self-explanatory, right? As I mentioned, it has more reasonable bandwidth usage. Actually, Raft has a reputation for being chatty. We found ways to improve on that. I'm going to cover that a little bit. And again, it doesn't give you cross-data center replication for free, but it opens the door, and there are existing systems that are cross-DC compatible and use Raft, specifically Raft, not a Raft-like thing, under the hood. So it's doable. It's reasonably easy to reason about, both for us and for the users. So what is Raft? It's a collection of algorithms, not a single thing. Don't compare it to Paxos. It's apples to oranges. That their collective goal is reaching consensus in a distributed system. It is implementer focused, so it was designed to be easier to explain, easier to reason about, specifically recovery and cluster membership changes. It is proven by now, and not just the fact that it has a formal specification. Several data services that you have used without knowing it adopted Raft extensively, as different as etcd console and CockroachDB. And I'm sure these days there is more. So with Raft, we have a number of nodes. So in this case, we have 3. Every Raft cluster has a leader, and all operations flow through it. And followers, well, they store replicas. So let's say a command comes in, like, hey, enqueue this message, right? So the leader has a log and a commit index. The log, as you can think of it, as an array for the purpose of this discussion. And the commit index is what's the latest operation that is known to be successfully committed on all nodes. So the leader tells its known followers, hey, please append this entry to your log, and we can see that the log of those 2 followers is empty in this case. And they do that. How exactly they commit, it doesn't matter, but let's just say that Raft is pretty I/O heavy, and it really tries to be reliable, and things should go to disk as quickly as possible, basically. So both followers, in this case, modify the log to have this index 1 operation in queue, and report success. And as soon as a quorum of them, so more than a half, reports to the leader does its own commit, increments the index, and reports success to the client. That's basically it. How exactly leader election happens, not very interesting. It's not particularly novel. Yeah, let's go back for a second. So when followers fail, this is not a Raft talk, so I'm not going to go into much detail, and then come back, or a new follower comes back, there is a way in Raft to calculate the delta reasonably efficiently and transfer just that. So there we go. It sounds pretty straightforward, right? That's how it should be. Unfortunately, most consensus protocols aren't. So yeah. So what's the state of quorum queues? They are reasonably polished. We have been working on them for slightly over a year, I think. I'm happy to report that its throughput beats mirrored queues because, well, ring-based topologies are not exactly known for efficiency. So even though Raft is very I/O heavy. We found ways to optimize that. So you can expect at least our tests, which do not represent every workload, but they demonstrate that it is at least as efficient as mirror queues. So you won't have to sacrifice things, well, at least in terms of throughput, if you want to switch to them. It passes a slightly modified Jepsen test. I say slightly modified because we discovered some possibly unintentional things in the Jepsen test. We just had to modify it slightly. Doesn't meaningfully change it. And it is available in RabbitMQ on GitHubs near you in a release called 3.8.0 Beta 1. I don't remember if it's public. If not, I will make it public as soon as I'm done with this talk. So you will be able to give it a try. So Quorum queues has been a year of work, and we had to implement a protocol which was not necessarily designed for this kind of system. And yeah, some of our team members talked about that in detail at other conferences, so you can search YouTube. But basically, we have our own from scratch Raft implementation in Erlang. You can find it on GitHub. It is heavily, it's not RabbitMQ specific. You can use it in any Erlang or Elixir project, but obviously it was designed to fit RabbitMQ needs well. It deviates from Raft a little bit, but in ways that we believe do not sacrifice correctness. It includes a pure availability library, which again is not a homegrown protocol. It's a paper that has been known for a long time. For some reason, it's not that widely used. And this is what reduces Raft's chatter, because in Raft, nodes periodically send each other basically heartbeats saying like, hey, I'm there. And if you have 10,000 queues, and that's 10,000, and they're all mirrored, and that's 10,000 Raft clusters, that generates like an unreasonable amount of traffic. So we just rely on this library instead of doing that chatter. Again, I don't think that sacrifices correctness, and that's a serious deviation. It is optimized for throughput as opposed to latency, but it adapts the way it does I/O. So if it has a huge backlog, it will basically f-sync in larger batches. And that helps with throughput, but not latency. If it doesn't have any backlog, it will f-sync in tiny batches, maybe sometimes as small as one message, right? That helps with latency and does not help with throughput. So yeah, there it is. So far, it sounds too good to be true, right? It's like this awesome implementation, which happens to be more efficient and doesn't reinvent any wheels and so on. Well, most distributed systems have some kind of trade-off. So what sucks about this? There has to be something, right? Well, Quorum queues have limitations. Specifically, they don't implement every feature, and we hope to narrow this gap over time, but we believe that certain features such as TTL don't necessarily make sense. Why would you care so much about your data and replicate it and care about the recovery? So basically overemphasize data safety and consistency, and then apply TTL to that so that it just to throw that data away. If you want to throw that data away because your consumers can no longer use it, well, your consumers should make that decision. RabbitMQ should keep things around, and TTL by definition means you don't keep things around. And don't let me get started on the thing that like clock synchronization in distributed system. There are all kinds of problems that you avoid by simply not supporting TTL. Well, queues themselves will support TTL. I'm talking about message TTL. Memory management is not getting any easier with Raft or whatnot. In fact, with Raft, it's harder because it's so I/O-oriented. So it remains an area where we might want to tweak things once or twice before 3.8. So far, it has been quite good because we wanted to, our best case scenario was reaching parity with mirrored queues. We already surpassed that. So maybe we should stop right here. But currently, Quorum queues keep their log in memory, which, yeah, if you cannot have an infinitely long, in air quotes, queue that way, right? We hope to address that. We will see how it goes and what happens to throughput. Yeah, ask me in a year. So, and as any major feature, it's obviously mature, and we need your help we're testing it, try to break it. We found plenty of ways to break it in the last year. We addressed them, but we cannot possibly test every workload or come up with every single way of using quorum queues or mirrored queues. So yeah, it's a new feature. I don't mean to discourage you. Just keep that in mind and don't deploy this first milestone into production just yet. So a little intermission. I mentioned that maybe not all queues should support every feature. So with this, we effectively introduced the concept of queue types, whether we liked it or not. So how about RabbitMQ today, so 3.7x, has all these features. So you can have a queue that is durable, orderly, mirrored, lazy, has TTL, has message TTL, has a length limit, has that ladder, has certain failure recovery settings, has exclusive consumers, and can be like sharded, so affected by plugins. So what are the chances that it can be implemented efficiently for every combination of those, or even most? It's probably unrealistic, right? So how about in the future of RabbitMQ, we have queue types that are workload specific. So some can be consensus that don't support TTL because maybe you don't need that if you need this kind of guarantees. And you have transient queues that by definition, they don't store anything on disk and don't do the pretty crazy memory management that regular RabbitMQ queues do today. But yeah, you don't expect them to do that. You can have infinite queues, so basically what lazy queues do today, maybe without some of the limitations. Yeah, you can have lower latency queues, whatever exactly that means. So that makes more sense to me, and I think I'm confident that our entire team believes this. So yeah, let's keep moving on. We have Auth2 support. What that means is you will be able to provide a JWT token as a username. Every JWT token has scopes, which are your permissions. They are translated to RabbitMQ permissions. So internally, this is not a break and change. Internally, nothing changes. You can still even combine that with LDAP if you want. I don't know if you would, why you would, but you can. We don't care how you obtain the token as long as RabbitMQ has a key to decrypt it and verify it. Management UI will use a specific authorization flow because web applications tend to do that in a certain way, right? Makes sense there. And efficiently supported clients will probably have some kind of token renewal because, well, you honestly don't want to deal with that. It's a bit annoying. JWT tokens by definition expire. So on a long-lived connections, you can run into a situation that your token has expired, but your application still intends to use that connection, right? So this has to be addressed. But we believe this is mostly a client library and application concern because RabbitMQ technically could renew your tokens, but maybe you don't want it to do that. It's just too much. So yeah, what's the state of this? It's a plugin. It's already done. The core part has been sitting there on GitHub for months. It will ship in the next milestone in 3.8. We just have to include it into the distribution. Management UI still needs a bit of work, but in my opinion, that's the easy part in Auth2 support. It targets Cloud Foundry UAA, which is a user authentication and authorization service, and via that Active Directory, because that's what the majority of UAA users use. So yeah, that's what we will test against for 3.8. So next generation schema storage. I already mentioned that RabbitMQ's internal schema database is very opinionated, and the way it recovers and handles failures just doesn't fit what distributed data service users expect today. So yeah, we would like to have something that makes sense when it comes to failure recovery for RabbitMQ, so that one part of the partition doesn't have to wipe itself out and completely sync. Something that can integrate with this unified operation log that I keep talking about. It can address certain scalability. Sorry, it can be an improvement in terms of scalability, but actually Amnesia, for what we use it for, does reasonably well there. What we don't like about it is the way it handles failures. We would like to have something that we can make the COA reasonably easy without doing a major re-architecture eventually. And well, Amnesia has other limitations that would be too much inside baseball. We don't care about them. Let's just say that Amnesia is a data store which is over 20 years old. So what are the chances that it will have major break-in changes to address some of its known problems? I think the probability of that is about 0. So by simply having something that doesn't heavily rely on Amnesia, we can increase our development iteration rate, and with high developer iterations usually come good products and improvements that ship sooner. At least that's what we believe at Pivotal. So we call this project Nevis. By the way, the Raft implementation is called Ra, which is a prefix in Raft and RabbitMQ, but also an Egyptian deity of some kind. Nevis is another, I think, Egyptian deities. Yeah, don't ask why. It's currently an area of experimentation. The idea is that because we don't like the distributed aspects of Amnesia, what if we replaced that but kept Amnesia's transaction local storage, because that part actually works reasonably well, even though it's over 20 years old. And it turns out that Amnesia is very extensible. In fact, it's unbelievable. I have never seen a data store where you can replace a transaction layer with your own. Again, I'm not saying that you should, but that's quite remarkable. So at this point, we don't think that Raft without extensions would be optimal for this kind of data store. But, well, because we have a Raft implementation, that's quite tempting, and that's what we're looking at. So, but yeah, Raft introduces higher latency, and for this kind of data store, we're not sure if we are willing to accept that trade-off. We will see what comes out of it. So mixed version clusters, this is possibly my favorite feature. So as you know, you cannot run a 3.7 cluster that has, say, a 3.6 node in it. And that primarily comes down to the fact that Amnesia actually has very specific ways of managing schema. If two nodes don't have matching schema, Amnesia will freak out, and one of the nodes will fail. So historically, RabbitMQ had very conservative restrictions. So as soon as you try to cluster two nodes, they will check a whole bunch of things. And if something doesn't look right, that operation fails. We relaxed some of those restrictions because they were not necessary. In fact, even in 3.6. And we are migrating to not doing version testing, doing capability testing as well, and using feature flags. So currently, we have a prototype. It's not merged. And I don't know if that will be what will ship in 3.8 exactly. But we have a prototype where you can cluster a 3.8 node and a 3.7 node and enable 3.8 features on that 3.8 node when you're ready. And everything, well, at least in the relatively basic tests we did, just works. So basically, some 3.8 features are not available until you enable them. And you will only be able to enable them once all of the nodes are on 3.8. So again, I'm not a fan of in-place upgrades, but it paves the way for relatively straightforward in-place upgrades. And we hope that, it almost seems to be too good to be true. So maybe that's all we have to do to enable this. Our internal APIs become pretty, if you're familiar with Erlang, they would seem pretty funny to you, because Erlang records are actually a nightmare when it comes to version compatibility and all. Erlang has a lot of features for distributed systems and hot code swapping, but its records are unbelievably archaic and non-extensible and actually make upgrades harder. But we use them, well, everyone uses them extensively. So we have our own API that avoids using records the way they're meant to be used in Erlang to work around this. But I think, well, that's the cost of doing business here, so to speak. So what's the state of mixed version clusters? So again, we have a pretty promising experiment. It's meant to simplify upgrades, so we don't expect people to run mixed versions for a long time. It honestly makes no sense, especially with feature flags. Why would you run a 3.8 node if you cannot use any of its features? Unfortunately, so long-running cluster is not a goal there. We cannot guarantee safety for every single workload because in a distributed system, sometimes the only way to address a problem is to address it in all nodes. If one of the nodes doesn't do the right thing, the rest is, might as well not be happening. But for, again, common workloads, so far so good. It needs more feedback. Once we merge it, we will definitely ask all of you to give it a try. So RabbitMQ 3.8, I keep referring to it. What is it going to include? We are certain that it will include Quorum queues, Auth2, hopefully initial mixed version cluster support. And yeah, there are minor technically break-in usability improvements. Nothing major, but there are certain things that we decided that maybe we shouldn't merge into 3.7. So that's it. How about RabbitMQ 3.9? Anyone interested in RabbitMQ 3.9 updates? We would like to get protocol agnostic core in 3.9, and we will see why when we discuss 4.0. Yes, there will be 4.0, and the rest is on the table. So if you have ideas about what you would like us to address, anything that's not like major break-in changes, let us know. And 4.0, finally, that's where next generation schema databus is going to ship. I don't know, everything else is like all the break-in changes we can fit. The last time RabbitMQ shipped a major version was 2012, I think. So we might introduce food replicators, tricorders, I don't know, transport beams. Yeah, you can tell I'm a Star Trek fan. So thank you, and let's open up for questions.
Is there a Docker image available for the data now?
We don't produce our own Docker image, but the Docker image maintained by the Docker community, I think they have previews as one of the Docker files. So because we haven't announced 3.8 beta 1 yet, they don't have that. But there will be hopefully reasonably soon. And I think, well, honestly, you can contribute it. It should be just a version bump.
Hi, thank you for this. Will the switch to Raft change like the deployment topology in something like Kubernetes, where currently you have, I think, the Sentinel pods or something like that, as well as the main pods? Will any of that change?
So Quorum queues is an incremental addition. It doesn't break anything. Your mirrored queues are not going to become Quorum queues overnight. As far as I understand, absolutely nothing changes except, and I should have mentioned this on the slide, I'm sorry, with Raft, you need to have the majority of your nodes online in order for the cluster to make progress. So if you use Quorum queues and you lose more than half of your nodes, those Quorum queues will reject all operations. That's how Raft is designed to work. And if you think about it, reaching a consensus in a system that doesn't have the majority of nodes, is it really possible? So that's the only major limitation. Another thing is, well, we will publish documentation around that. There are certain things that operators need to be aware of, but basically it's almost as non-breaking as we can possibly make it. As far as deployments, specifically Kubernetes go, I don't think that anything would change, except for this day 2 operations kind of moment that you have to keep in mind. There is a question in the back.
Yes. So what's the target release for different queue types you were talking about?
Well, effectively 3.8, because we already have 2 types. We have Quorum queues, we have mirrored queues, and one specific case of mirrored queues is a non-mirrored queue, right? With a single replica. We need to refactor some things internally. We probably will do that before 3.8. From there, because a new queue type is an incremental addition, just like Quorum queue is, we will see how it goes. Again, we don't really have anything beyond protocol agnostic core planned for 3.9, but I can see how we can introduce a new queue type. There are some, I'm not going to name them, but we have some pretty crazy just queue type experiments that some of our team members did, which it's basically blasphemy. No, I'm kidding. But yeah, it introduces features not associated with RabbitMQ necessarily. Are we going to ship them? I don't know. This is not a promise of delivery. Don't make any purchasing decisions based on that. Over there.
Thank you. When is it planned to release the version 3.8?
We don't promise any ATA. Sometime next year is all I can say. And also 3.7 will be supported for some time after 3.8 ships. So there will be a migration period anyway.
How far advanced is Nevis?
An area of active research. So it's not vaporware, but it's not something that not only merged, but we are ready to like, hey, here's a pull request, let's all QA and try to break it. It's very much early days. By the way, speaking of that, so even if Nevis was ready to be merged, 4.0 will not ship before 3.9 most likely, and definitely not before 3.8. So your actual availability date will be a little bit further in the future.
Nevis is just a fork of Mnesia?
It's not a fork of Mnesia, it's an extension of Mnesia that uses Mnesia in a node local way and replaces replication. Well, the entire distribution layer, to be fair.
Did you say the Quorum queues will have data center awareness? So I can put them in different...
Well, because they are
availability
structured
zones.
around the log, we believe that it's not as scary as it sounds to make them data center aware one day. They are not in 3.8 because, well, we have to ship this thing first, get it reasonably mature, and then continue working on it. So the work on Quorum queues, Raft, queue types, and so on will obviously not stop with 3.8, but at some point we have to ship something, especially since it will potentially include mixed version clusters and simplified upgrades. So we're not trying to squeeze everything we can into 3.8. It makes no sense. It's also not the pivotal philosophy. I had to mention that.
Hi, thanks for the talk. Are there any plans to change the mirrored queue linear algorithm to something better?
I think the only change to mirrored queues at some point will be they just go away. That's the only thing we can make. Because if you think about it, replacing that algorithm as a break and change, there is no way to not make it breaking. I think most people would not appreciate that. So basically, their eventual fate is just being deprecated and then removed. But don't ask me when it's going to happen. They have been around for many years. Right, well, you can also ask me questions in the hallway. Thank you very much.